Welcome to the Math Record. Today we'll cover every graph transformation. This video will be chapter 4 of our Precalculus class. In this video, we will learn about the three main types of transformations: phase shifts, stretches and compressions, and reflections. First off, let's learn about phase shifts. Sorry about that. Phase shifts, okay. So phase shifts are basically any equation. Let's say you have a quadratic because it's easier to show. We're gonna use quadratics the entire time because it's it's easier to show basically. But you could use this for any graph. So if you wanna have a quadratic like this, basically if you want phase shifts are if you wanna move it up, you wanna move it down, you wanna move it to the right, or you wanna move it to the left. That's what phase shifts are. So those are the three main shifts: up, down, left, and right. So how do you move it up? Well, if you have an equation called f of x, right? That's your original equation. Then to move it up, you just add a. That's all you have to do. So if you want to move f of x up 2, just add 2. If you want to move it f of x up 3, just add 3. Basically that simple. Now phase shifts for going down. If f of x plus a is moving it up, then f of x minus a is moving it down. So if you want to move it down 2, it's just f of x minus 2. You move it down 3, f of x minus 3. And now if you want to move it to the right. Right and left are a little bit more tricky. It's you might get these as mistakes. So it's basically, if you have an equation called f of x, to move it to the right, you put f of x minus a. It looks like if you're minusing, it's supposed to go to the left, but it doesn't. It's f minus a is going to the right. So you want to move the equation f of x to the right by 2. It's f of x minus 2, and x minus 2 is in the parentheses. You want to move it right by 3, it's x minus 3 in the parentheses. Okay? And now to move it left. If you want to have f of x, right? You set f of x minus a is to the right, then f of x plus a in the parentheses would be to the left. So you want to move it 2 to the left, it's f x plus 2. You want to move it to the 2 to, if you want it move 3 to the left, it will be x plus 3. If I set this f of x plus 2 is equal to 2 to the right, it's not, it's to the left. I'm sorry about that, I might have misspoken. So those are all phase shifts. It moves up, down, left, and right. And now let's talk about the second type of graph transformation, which talks about stretches and compressions. Stretches and compressions are basically, let's say you have an equation, f of x, let's say a quadratic, and you want to move it. There's two types. There's the horizontal and there's the verticals. So for horizontals, a horizontal stretch would be like if you want to move it up more like that. So if this is stretched out, if these lines are stretched out, that's a horizontal stretch. A horizontal compression, if it's not stretched out, then it's gonna move in more. So it's basically like this. It kind of doesn't look that well, but it's basically like that. So if these lines were getting close to each other, basically that's a horizontal compression. Now then there's the vertical stretch. So a vertical stretch, well, if this graph got pulled up and pulled down at the same time, so it's gonna be like this, a vertical stretch. Now if you want a vertical compression, it would be like if the graph was getting pushed down and pushed up right here, pushed up and pushed down, so then it would kind of get smushed. So it kind of gets like this, you know. See how that works? So those are the two types, vertical and horizontal, or in the order which is horizontal and vertical. So how do you calculate that? Let's go with horizontal first. Horizontal says that if you have an equation called f of x, then to horizontally like compress and stretch it, you got to put f of a of x, where a of x is inside basically. So if so for it to stretch, a has to be between 0 and 1. A has to be for it to stretch. So if you want to stretch it by 2, then you're going to have f of 1/2 a. Why 1/2 though? Well, basically, if it's 0 is less than a is less than 1, it's going to get stretched by a factor of 1 over a. So it's the reciprocal of what you want, basically. So if you want to stretch it by 1/2, you guys put 1/2 a. Because just think about it. Imagine you had to go twice the distance amount, so then you have to cancel out that 1/2 to get the regular value. Because let's say f of 1, right? You got what, f of 1? But you want f of 1 now again. So since it's stretched, it's stretched by 2, so it's 2 times more to the right. Imagine that, right? So then you have to go to 2 to get f of 1. You see how that works? So that's basically what you have to do. You have to do the reciprocal. So if it's stretched by a factor of by 2, you gotta put 1/2 basically. So a would be equal to 1/2. So then it would be like 1 over 1/2 is 2. So if you want to get stretched by a factor of 1/3, you put 1/3. So whatever you want to get stretched by a factor of, put 1 over that number. Put the reciprocal. Now, if you want to get compressed, a has to be greater than 1 for it to be compressed vertically. It will be compressed by a factor of 1 over a, basically. So if you want to compress it by a factor of 2, you gotta put f of a, let's say 2 of x. So basically now you want to let's say you want f of 2, right? You want to compress it. So it's got to be 2 times more to the right, to the left this time, right? Because now you imagine where the graph is placed now and move that 2 times to the left. But it's not going to go negative. It's just got to go 2 times left. It's going to compress. So think about that. So then if it's f of 2, right? So where it's supposed to be 2 times on the left, it's supposed to be f of 1. So that's what you put down. You put f of 1 to make f of 2 in here. So that makes sense. So it will be compressed by a factor of 1/2. Because you have to like compress it by that number basically. So that's the horizontal compressions and stretch. Now, instead of saying a is outside, a is inside, let's say a is outside. So it's a times f of x. This is what we're going to have as a vertical stretch and compression. So if a is between 0 and 1, then it's going to get compressed it's going to get vertically compressed by a factor of a. So basically, it's going to be like a graph like this, and it's going to get compressed down. It's going to move down, basically. So let's say you want to compress it by a factor of like 2. Compress it by a factor of like 0.5. Then you're going to have 0.5 f of x. Because think about it, whatever the graph is, now it's going to be 0.5, it'll be 0.5 times smaller. Because you have f of 1, and then f of 1 times 0.5, so it's going to get half the distance. So you have to have, like, where the value is just going to be half, basically. So that's how it works. So a vertical compression is more intuitive, so it's more logical. So if, let's say, a now is greater than 1, then we're going to have a vertical stretch by a factor of a. So basically, if you have like 2 times f of x, now the equation is 2 times bigger. So it's stretched by a factor of 2. You see how that works? Whatever it says by a factor of is basically telling you what you have to multiply the equation by, basically. So that's for stretches and compression. Now, we have one more, which talks about reflections. So, reflections. So imagine a graph like this, and you want to, now let's say a graph right here, right? And you want to reflect it across the x-axis, and you want to make it like this. Or you want to reflect it across the y-axis, so it goes from here to over here. See? So that's called reflections across the y-axis and across the x-axis. The y-axis and the x-axis. So those are the reflections. So in our case with horizontal and vertical compressions, we have the cases where a is greater than 0 is less than 1, or a is greater than 1. So what happens if a is less than 1 this time? So it's got to go negative. Well, that's what we're going to do. That's what reflections cases are. So we're going to if we have an equation called f of x, right? And we put negative f of x, we're going to reflect it across the x-axis. Because just think about it. If you have an equation like this, right? And whatever points that are positive, it's just going to turn negative. So it's just going to reflect over the x-axis. So that's called reflection over the x-axis. If you just put a negative in front of the equation. Now what have we? Now let's put a negative inside that equation. So it's f of negative x, where negative x is inside the parentheses. Then basically, let's say you have an equation like this, then it's got to go here. Because imagine you have 0.1, right? You have 1 here. Then it's going to be, 1 here, right? It's going to be positive, but now you're going to have that exact same point, but now negative. So it's going to be negative 1, and now it's going to be at that point. So it's got to be reflected across the the y-axis right here. So those are the two cases for reflections. So overall, those are like the three main cases: phase shifts, stretches and compressions, and reflections. So overall, you could just look at this. So phase shifts, overall in summary, if you have f of x as the original equation, then if you plus a, then it moves a up. If you minus a, it moves a down. And you plus a inside the equation, you move a to the left. And you minus a inside the equation, you move a to the right. And for stretches and compressions, if a is inside with a of x, and it's from 0 to 1, it stretches by a factor of 1/2. 1 over a, the reciprocal of a. If a is greater than 1, then it's going to get horizontally compressed by a factor of 1 over a. And if we have a as outside the equation, and it's between 0 and 1, it's got to get vertically compressed by 1 over a. And if a is greater than 1, it's going to get vertically stretched by 1 over a. And the reflections, if it's negative 1 on the outside, or whatever, it's just negative on the outside, it's just had to be 1, it's going to be reflected across the x-axis. And f of negative x is, if negative is inside the equation, it would be reflected across the y-axis. You see how all these work? Sometimes these, you can take a screenshot of this if you want for you to memorize. But basically, what you wanna, what they usually test you on these type of questions is they're gonna put multiples of these equations. So let's say you have a multiple of these transformations. So let's say you have an equation called f of x. They might just put like negative 2x x minus 3 plus like 5. So basically, you just want to follow the orders of operation. So if this is minus 3, right, this has to go to the right. So you move 3 to the right, right? And then you see the negative 2, and you see 2 first. So you have so you get compressed vertically by 2. and then you reflect across the y, this is negative outside, across the I mean not the y, the axes, and then you add 5 up. So you phase shift 5 up. So that's basically how you do it. That's what they usually do. They put a bunch of these equations to put a bunch of these transformations together. Sometimes it's not like always that big. Sometimes it's just like -2 f of x, or just like negative f of x plus 5, and you just follow the orders of operation and see how it works. Sometimes it's a little bit more complicated, but you'll learn the tricks. You learn the tips and tricks like along the way, basically. As you solve more of the equations, you see the patterns. So, overall, in summary, basically, just memorize these basically rules, and you'll be fine. Anyways, thanks for watching, and I'll see you at the next math record.